Alright, hello everyone. Welcome back. I'm going to be going over some more airflow examples today. Um, Bear with me here. After an hour of already pre-recording this video, I realized that something went wrong with the recording process, so this is round two. Hopefully now we don't have any issues with me recording. So what I'm going to be doing today is I'm just going to be going over the solutions of the exercises in part one of the airflow data pipeline portion of the course. I'm going to be going over the GUI, or the online user interface, which Airflow provides for us, so that we can actually see our DAGs, our tasks, and get some feedback as far as task completion, or if we run into failures, take a look at the logging, as well as verifying that the code has been updated and such. We'll also cover creating our connections and setting variables. Alright, so diving in now. So here we're just going to create a very simple DAG. So DAG stands for Directive Acyclical Graph. A directive acyclical graph contains a few different nodes. So each node within Airflow is going to be an individual task. So it could be something like collecting data from a S3. It could be possibly grabbing information from a website, so doing an HTTP request. It could be many different things. As you'll see, Airflow has tons of capabilities and allows for you to work with many third-party libraries. In this first example, we're just going to be using the Python operator. So you can think of operators as those tasks. So each node within our DAG is going to perform a certain operation. In this example, we're just going to go ahead and create a hello world function. In our hello world function, we're going to call logging.info hello world. Next, we have to define our DAG. The DAG is going to be what contains that function or that task that we want to have performed. In order to define the DAG, we have to first provide the DAG ID. So it's going to be the name of the DAG. In our case, just lesson1.solution1. Next, you have to define the date at which you want to actually start running the DAG. Here I'm just going to use datetime.datetime.now, which returns a date object of the current time on my local system. So now to define the task. We say greet_task equals Python operator, because we're going to be working with just a Python function here. Here we provide the parameters task ID equals hello world task. Now this is where we provide the function we wrote. We say Python callable equals hello world. Finally, we have to provide the DAG to which this task belongs to. So we say DAG is equal to DAG, which is the DAG that we defined right here, with the ID of lesson1.solution1. Okay, so now that we have our code written, we can come over here within the workspace. We say /op/airflow/start.sh, which will run our bash shell script. Okay, so we have an error here, and that is because I had defined something in exercise 3, but we're not going to go ahead and pay attention to that. Everything else should be up and running. So if you go ahead over here in the bottom right, and you click Access Airflow, we should get a pop-up into our URL, which I already have open here. I'm going to go ahead and refresh that so everything's okay. Let's see if I can actually just go ahead and refresh everything here. Bear with me here. I'm going to try and start from scratch. So let's go ahead and run that command again, and hopefully we get a brand new one. Okay, we see that our Airflow web server is ready, and we can click the link. Should open up in your web browser. Okay, unfortunately I still have all the information from last time. That is okay. Okay, there we go. So we had defined the DAG lesson 1.exercise 1. So actually it's kind of useful that all of these have already run, because when you're running this in the online environment, Airflow does tend to take quite a long time. So now that I've already run all of these last time, I'll be able to just kind of show you what results. So here we have the off and on button. So you use that toggle to pause a DAG when you don't want to run it. Schedule won't schedule new task instances for a paused DAG. Tasks already running at pause time won't be affected. So here we have our DAG name. In our case, it was lesson 1.exercise 1. You can see that we have the schedule here, the owner, and because I've already run this, we already have the success. You can see the last runtime, and then you can see the amount of times the DAG has run. Just make this a little bit bigger here so we can see everything. Okay, so over here, this is how you would actually start the DAG's operations. So we can go ahead, we'll just go ahead and hit that for. As you can see now, we get the green oval here indicating that the DAG is running. And over here we can see that we have one task in the queue. So it's currently running and it has not yet completed. See if I refresh that. Okay, it's still running. So over here we have the logs. And first I'm going to go ahead, let's take a look at the code view here. So one thing that I did add to this file that wasn't originally there was this comment here where I said name or DAG ID. So we can see that this is in fact the most updated code of which we wrote. So it's very important to make sure that you check that code and ensure that all of your updates have been made appropriately. In order to get back to the Airflow UI main menu, you would just click that upper left Airflow logo. So in order to check the logs, we can click here on the logs, and we can get some detailed information here about our DAG that has run. So a lot of this is just exclusively Airflow default information, but we can see that we have our tasks here, the date that it's run, and the date time, and so on. Here we can see that we just triggered it. Excuse me. Okay, so just to kind of summarize what we have done here, we defined a function which we will later call with a Python operator. You can think of the operators as the individual tasks or nodes of our DAG that we want to run. So we have to first define a task, which then we put into the DAG, and then that task will be performed and eventually completed. Okay, so we can see here in our DAG UI that we have the schedule column. So in many cases, you will want to run these operations automatically at various time intervals. Airflow provides many different ways in which we can run them. For example, we can run it hourly, daily, monthly, yearly, depending on the amount of calls that you need to do. How often do you need to update this data? So one thing to be wary of is that if you're using a service like AWS, very large data calls could be quite expensive, so be wary when running this. You should be fine within this course, but once you take these skills elsewhere into your work life, just be cautious not to possibly schedule more than you need to, as the cost could be very great. So in order to define our schedules within the DAG, so this is going to be exactly the same as our last DAG definition. The only difference here is that now within the DAG we provide this new schedule interval parameter. Schedule interval we're going to set here is going to be equal to daily. So in order to provide the preset variables for the schedules in Airflow, you'll just notice that we have this @ symbol here. So if we wanted to, we could change this to @monthly. You could also change it to @yearly. Make it just run once a year, starting at the start date here. So in this case, we're actually going to define the start date equal to a date 2 days ago. So it's going to retroactively begin our DAG. Once again here, we just have the single task, which is our hello world function that we called up here, which should log to the logging info hello world. So we hop back over here to the UI. We can go ahead and turn this on. Let's see, let's refresh this. Take a look at our code. Okay. Let's save that. Oops. I'm going to go ahead and run the op/airflow/start sh once again. Go ahead, start the server. So hopefully we can see those changes that I did to the schedule interval. I'm just going to close that. Okay, I think I must have interrupted it. Let's try that one more time here. It should. Oh, I'm sorry, I forgot to hit the Access Airflow button. That's why it didn't open. Bear with me here. Okay, Airflow web server is ready. I'm going to go ahead and open that up. Now if we check exercise 2, we should be able to see our changes that we just made. And let's see if I refresh this. Whoops. Sorry, once again, we'll check the code. Doesn't seem that it's picking up my change. I think it's because I've opened it and I'm working with all of these multiple files, so the changes aren't being reflected right now. Anyways, moving on. Let's close that up. We're going to jump into exercise 3. So as I said, the DAG should consist, in most cases, you don't just want to perform one task. The whole point of a pipeline is that we have various tasks, multiple tasks, that all kind of have a dependence or interdependence upon each other. So it's going to be a progressive process where, say, we pull data from S3. We may want to do some transformations on it, maybe do some data cleaning, do some aggregations. And then finally, we want to maybe load it to some business intelligence software, such as Tableau, or just maybe load it into Redshift and create a database. So in order to define this interdependence or this, I guess this flow of information, Airflow provides us a few ways to do it. So here we have now 4 functions. We have a hello world function, we have an addition function, subtraction, and division. All they're doing is they're going to print 2 plus 2 equals the result of 2 plus 2, 6 minus 2 equals the result of 6 minus 2, and then we have 10 divided by 2 equals 10, the result of 10 divided by 2, but we're going to convert it to an int for just to kind of change the format. What will be returned in Python is a float, so we just want to convert it to an integer. Here we define our DAG. We have a schedule interval of hourly, and we're going to start our start date 1 day in the past by providing the datetime.time delta, days equals 1. So because we have now 4 functions, we are going to go ahead and create 4 tasks, 1 for each function that we defined. So once again, we use our Python operator. We have to set the task ID. We provide to the Python callable parameter hello world. And then we have to specify the DAG which it belongs to, which is lesson1.solution3. Once again, we do the same thing for our addition task, subtraction task, and division task. Okay, so now to actually kind of define the flow of information here, what we can do is we can use these right carets here. So we can say hello world task, right caret, goes to addition task. So what that means is that the hello world task is the first node or first task that we want to perform, and after it's performed, it passes its information over to the addition task. In this example, we're not actually passing any information between the two, but basically what it's saying is that we want to perform the hello world task before the addition task, and the addition task depends on the successful completion of the hello world task. Likewise, we have the hello world task is the, I guess, dependent, or I'm sorry, is the parent of the subtraction task, whereas the subtraction task is the child of the hello world task, or dependent. You can think of it as a dependent. So finally, we have subtraction task goes to the division task. Also, we have the addition task goes to the division task. So the way you can kind of visualize this in your mind is that we have our hello world task as node 1. It has an edge that then leads to addition task. It also has an edge that goes to the subtraction task. So it has basically 2 branches shooting off of it. Finally, both of those branches, the addition and or both of those nodes or leaves, if you want to think of it as a tree, then have edges which connect it to finally the division task. So the division task has 2 dependents, or I'm sorry, 2 parents, subtraction and addition. So the resulting DAG is sort of, if you want to visualize it, would be kind of like a diamond, where we have our hello world task as node number 1, has 2 branches, addition and subtraction, and then those eventually both connect to the division task at the end. Okay, so this was solution 3. Let's go back, jump back over here to the Airflow UI, and let's take a look at the code. So you can see here we have all of our functions defined, we have our operators, and then finally we have our configuration for our dependencies. So everything looks good there. We can see here that we've actually had 25 successful DAG runs. And I've obviously left this open because we have an @hourly schedule, and this has just been running all overnight. And let's just go ahead and trigger it one more time here. Why not? So what that's actually going to be doing, if I trigger it again, is that I've just now reset that start time. So be wary when hitting that trigger button. If you have a specific start time that you want these to be running, if you go ahead and trigger the event again, then the code reruns and now your start date has changed. So well, that's one thing to keep in mind. I'm going to go over here to solution 4. Okay, so now we're going to get into some more interesting things, which will be a little bit more advanced, but will kind of open up the true power of Airflow. And that is in the form of S3 hooks. So what it does is it allows us to connect to S3, input our user information, our AWS credentials, and then retrieve data from various data sources. So we're going to be importing some new libraries here, or not new libraries, but some new modules. We're going to say from airflow.models, we're going to import variable. Once again, we're going to be using our Python operator. Also from airflow.hooks.s3hook, we're going to import s3hook. So here, we're just going to be defining a function which is going to access an S3 bucket, iterate through the keys in that bucket, and then just return them as the log. So here we define hook equals S3hook, the AWS connection ID, we set that as AWS credentials, our bucket equals variable.get S3 bucket, logging.info, we're just going to have basically a list of keys from the bucket. Our keys is equal to hook.listKeys of the bucket. Finally, for key and keys, we want to log the bucket that it belongs to and then the individual key name. Next, we just define the DAG. We have a start time or start date equals the datetime.datetime.now object. And then we have our task here, which we call list task, which is a Python operator with an ID of list keys. Our Python callable is equal to our list keys function, which we defined up here. And then we set the DAG equal to the DAG, which we defined, lesson1.solution4. Okay, so now to jump over to the Airflow UI. So we saw there that we had our variable and we have a connection ID. So Airflow makes it very easy to manage your credentials as well as other data sources in which you will be accessing regularly. How you can check that out is you come up here to the admin tab, you click that, and first we'll take a look at the connections. So here we have a bunch of default connections. You can see we have Cassandra, we have Hive, MySQL, Postgres, and so on. When you want to create a new one, you just click here, create. You establish a connection ID. So in the function, we had AWS credentials. Our connection type, you would just define it as AWS or S3. Post, you provide the schema, which is going to be the database. Here you provide your login, so you're going to be your username and password. And then you can specify which port you want on there, as well as any extra information. So now the variables. So this is where you will define particular S3 buckets which you want to access. So we can come over here, click Create. So the key is going to be the name of the bucket. In the val, you will actually provide the actual particular file that you want to access within that bucket. And it's as easy as that. So coming back here, we're running solution 4. So I have not defined my environments or my credentials within it, so I was unable to run it. But please feel free to refer to the video if you need a refresher on actually how you can input that information. I myself, I just kind of referred back to my old config files where I had my Amazon information stored. In the videos, you can see that the guy uses a password manager, which is very useful add-on that I have not yet gotten, but I definitely need to if I want to manage all of these various passwords and stuff effectively. Okay, let's go ahead, jump over to solution 5 here. So we're going to be doing something a little bit differently here. And we're going to talk about context. So providing context to a task opens up quite a few various variables which return information. They're stored as key value pairs. And in order to be able to access this information, you can do it like such. By using the args and kwargs parameters within a function, by simply putting a asterisk args and double asterisk kwargs. So kwarg stands for keyword arguments. What it expects is a Python dictionary. And in order to access this information, we'll simply do something like logging.info. Execution date is kwargs, and then we're going to access the DS key. DS is going to return a datetime object. I believe it's strictly a date object with no seconds. If we want to access the run ID and print out a string that says my run ID is, so we provide that curly brace. Within it we say kwargs, and we want the key of run ID. Previous DS equals kwargs.get previous DS. So now we're just going to provide a check here. So if there is a previous DS, so if something is returned by this variable here, and it's not just none, because if there is no previous date that it was run, this will just default to false, and then this won't run. But if it does return something, we want to log my previous one was on previous DS. Next DS equals kwargs.get next DS. So next DS is another variable that will actually show you the next time that the DAG is scheduled to run. So if that is a value and it actually does exist, we want to log that information. Here we're just defining our DAG again. This time we're going to actually have a retroactive start date of 2 days ago, setting the schedule interval equal to @daily. So importantly, when we're calling our task, we need to provide a new argument here. That argument is provide context, and we want to set that to true. By providing this provide context parameter is what allows us to access these quarks and return the values that are associated with it. Okay, now to wrap it up, we're going to go over to exercise 6 here, and we're going to build an S3 to Redshift DAG. So we have two new hooks here. It's going to be the AWS hook and the Postgres hook. So if you remember, Redshift and Postgres are basically, well, Redshift is kind of a built upon Postgres and made in such a way that it runs columnar storage. But at the foundation of it all is Postgres. So we're going to be using the Postgres hook in order to access Redshift. Here we have a Postgres operator, and then we have our Python operator. We're also going to import SQL statements. So first we define our Python operator here, or Python function, which will then be loaded into a Python operator. Here we just say define load data to Redshift. We provide the args and the quargs. AWS hook is equal to our AWS hook method, which we imported, and then we provided the credentials. We say the credentials is equal to AWS hook dot get credentials. So now we have our credentials. We can go ahead and use our Redshift hook by saying Postgres hook, and then we have the connection of Redshift. Next, we can go ahead and run Redshift hook dot run SQL statements dot copy all trips SQL dot format credentials, provide the access key and the secret key. We define the DAG here, providing the start date. Then we have a create table equals a Postgres operator. We give it a task ID because this is a task. It's going to be on one of the nodes within our DAG. We set the DAG that it's going to be part of by saying DAG equals the DAG. Our Postgres connection ID is equal to Redshift. And then we have the SQL. So SQL equals SQL statements that create trips table SQL. Now we're going to create another task, which is going to load the data from S3 to Redshift. It's a Python operator that's going to actually use the function that we defined up here. So we provide the task ID, we set the DAG, and then we pass in that load data to Redshift to the Python callable. Finally, we have our final task, which is going to be location traffic task. Equal to Postgres operator. We provide the task ID, the DAG, the Postgres connection ID equal to Redshift, and finally we have the SQL. So SQL equals SQL statements dot location traffic SQL. Here we define the dependency. So first we're creating the table, then we copy it to Redshift. Then from Redshift, we create our SQL. Alright, so just to kind of show you guys where some of these resources are, you can simply type Airflow documentation in Google. Click over here, and you will find a wide variety of resources available to you on these subjects. So let's go ahead and take a look at all of the various operators that are available to us. We can see here we have a full list of all of the various operator methods that are available in Airflow. So depending on the technologies that you or your organization use, it's be useful to look over Airflow and see if they actually do have anything available to you. Another thing we could take a look at are the hooks. So the contrib are the hooks that have been contributed by the open source community. They have not become an official part of the Airflow library yet, but that doesn't mean that they won't be added soon enough. We can see we have our Cassandra hook here. We have an AWS hook, which we have actually just used. And Azure, we can see many various third-party services that Airflow allows you to access. Anyways, guys, this wraps up this video of the week. If you have any questions about the content, please feel free to reach out to me on Slack, and I will get back to you as soon as possible. I just want to say you guys are doing a great job. Keep up the pace here. We're at the final stretch. The course ends in about a month and one more week, so we have 5 weeks to wrap up this project and finally the capstone project. If there's anything I can do to assist you guys in pushing you over that finish line, please feel free to reach out. I am available to assist you in anything you guys may need. Anyways, hope you have a great week, and we'll see each other soon. Take care.